My name is Michael W. Fox. I am a veterinarian, and I have been following developments in genetic engineering of animals, plants, and microorganisms that I want to share with you. We should all be concerned about this new technology because, true to the title of my latest book on this subject, it is taking us beyond evolution. What lies in store is a genetically altered future of plants, animals, the earth, and humans. Genetic engineering biotechnology, ethical, economic, and environmental concerns. Welcome to the genetic age. Biotechnologists are developing a variety of genetic engineering techniques to produce a host of new products and life forms. There is the promise of cures for various diseases like alcoholism, cystic fibrosis, and kidney disease. Pigs are being bioengineered to produce human hemoglobin to serve as human blood donors. Other pigs have been given human immune systems so they can serve as blood and organ donors for people needing new kidneys and hearts. Various crops are being engineered to produce their own insecticides to fight common insect pests. Even the genes of spiders that produce venom are being isolated and spliced into various edible plants to help combat insect pests, many of which are now resistant to chemical pesticides. Bacteria have been engineered to carry new genes that make them manufacture a variety of new drugs like interferon, insulin, growth hormone, and food additives such as vegetable rennet for cheese. With this new technology comes a new generation of drugs, vaccines, and diagnostic kits that benefit humans and animals alike. But there are risks and costs, as well as benefits, that genetic engineering biotechnology brings. We know nothing about the risks of releasing genetically engineered biopesticides as is proposed for the control of myriad insect pests like the pine beauty moth. Such release, as a purportedly safer alternative to spraying chemical pesticides, might not be needed if more natural, ecologically based farming and agroforestry practices were adopted. The truth is, we do not know the long-term ecological and economic risks of releasing genetically engineered life forms into the environment. Industrial methods of production of food are proving to be economically and environmentally catastrophic. Using biotechnology to keep these methods operating is, in spite of political paralysis, publicly unacceptable. The wholesale use of veterinary drugs and vaccines to keep farm animals productive in factory environments that cause them sickness and suffering, as well as harm to humans who work therein, is also unacceptable. Without careful deliberation and public involvement in the decision-making process of how this new technology is applied and of its consequences, the very integrity and future of creation may be irreparably disrupted at great cost to future generations. We have acquired a godlike power over Earth's creation via our dominion over the genes of life. If we do not use this newfound power to heal the Earth by healing ourselves, and heal ourselves by healing the Earth, then the suffering of humanity and the desecration of the environment will continue. Are we opening Pandora's box, releasing forces about which we know so little, but whose cumulative domino effect could be economically and environmentally devastating? This technology is being developed and heavily invested in by the petrochemical, food, and pharmaceutical industrial complex. We face a rising biotechnocracy that historically has had little or no respect for the earth, nor sense of transgenerational equity, which means respect and concern for future generations. It has profited from pesticides, and grown and prospered regardless of environmental and public health concerns, and it has profited royally from treating infants and adults who sicken in part as a consequence of these activities. The hopes of a world without disease, which genetic engineering pundits have proclaimed, are as unfounded as fears of monster animals being created by mad scientist gene jockeys. But concerns about the escape of genetically engineered fish, like trout and salmon containing the growth genes of other species that are being developed for commercial fish farming, and their potentially harmful ecological consequences are legitimate concerns. As of May 1993, the USDA and the EPA had approved nearly 1,000 releases of genetically engineered organisms into the environment for agricultural field tests. This sanguine attitude toward potential environmental risks is not rational, considering the fact that newly engineered genetic traits in crops can be passed on to other plants, especially weeds. The potential risks of pharmaceutical-producing transgenic crops to insects, birds, and other wildlife is an issue that will make confinement production of certain crop products an ethical and ecological imperative. Byproducts of such crops may not be safe as animal feed or compost. Several patented varieties of crops like corn and wheat have been engineered to be resistant to the patent holder's herbicides, the continuing use of which is ecologically imprudent. Various crops have been given bacterial genes to produce insecticides like Bacillus thuringiensis in order to repel and kill pests. But this is a short-lived miracle, since pests like the diamondback moth caterpillar quickly develop resistance. These and other developments in agricultural biotechnology are not based on the principles of a humane, sustainable, and socially just agriculture, in spite of the promises of a safer, cheaper, and plentiful supply of food for all. The rush to genetically engineer and patent new life forms holds great promise for investors and for those seeking a monopolistic control over the entire food and drug industry. There is a clear and disturbing trend to monopolize seed stocks. This move by the multinational petrochemical, food and pharmaceutical industry complex will mean that neither farmers nor consumers will have any control or choice over what and how crops are raised, unless genetically engineered foods are appropriately labeled in the marketplace, including products from genetically engineered animals and animals treated with genetically engineered products like growth hormone. Furthermore, the development of new crops like rapeseed and canola to produce specialty oils and engineering bacteria to produce vanilla in fermentation vats will cause great harm to the export markets of developing nations, whose vanilla, pyrethrum, coconut oil, cocoa butter, and palm kernel oil economies would be devastated. Many developing nations have not attained sustainable self-sufficiency because colonial agricultural development programs have encouraged them to produce various crops for export to the industrial world, especially to feed livestock. Local people facing hunger and poverty then farm erodible marginal land, destroying wildlife habitat in order to feed themselves and their own livestock. The preservation of cultural, agricultural, and biological diversity go hand in hand. Yet, industrial agriculture has been a major cause of the loss of both. When indigenous peoples lose their local knowledge and sustainable farming practices, they become dependent upon the global industrial oligopolis as participatory consumers and contract laborers, or else they join the disenfranchised, alienated, and even starving multitudes. Fears about the loss of genetic resources underlie the growing international acceptance of the International Biodiversity Convention. We need to use biotechnology wisely, such as to strengthen and widen the genetic base of our highly inbred varieties of cereals, fruits, and vegetables. This will help them to be productive under the increasingly inhospitable climatic and soil conditions that we have in part brought on ourselves. Seeds, like indigenous wisdom, are best conserved by being continually sown and harvested where they were first developed. The equity and social justice issues of conventional industrial agriculture are being compounded by agricultural biotechnology. This technology represents another costly off-farm input. This means that those farmers who adopt biotechnology will see their profit margins decline further as the input and market sector agribusiness profits increase. Farmers will likely lose all independence and become contract growers under the yoke of corporate feudalism. If these trends continue, industrial agriculture under this form of corporate socialism is likely to become increasingly dysfunctional, like the regime of state capitalism that destroyed agriculture under the former Soviet government. Industrial agriculture has contributed to the loss of over 400,000 family farms in the U.S. between 1980 and 1990. It has also contributed to the loss of biodiversity, not only in the living soil itself, but also by obliterating natural ecosystems like savanna grasslands to produce various agricultural commodities. This, in turn, has led to serious soil degradation in the U.S. and in many other parts of the world. By so doing, the farmer's dictum that we do not inherit the land, we borrow it from our children, has been ignored. Conventional industrial agriculture has contaminated surface and groundwater globally with harmful agricultural chemicals. The antidote lies not in new biotechnology fixes, but in the way crops are raised, not as monocultures, but in ecologically sound and sustainable ways. Industrial agriculture has also brought us intensive factory poultry and livestock production systems. These have been shown to cause animals to suffer stress, distress, and disease. They are highly inefficient and inhumane systems, and a full cost accountability of energy and feed utilization, environmental damage, and costs of animal manure waste management is long overdue. Surface and groundwater pollution from animal wastes are a serious environmental and public health problem. Using biotechnology to correct these pollution problems, so-called bioremediation, is not acceptable if no efforts are made to change the agricultural system and especially to raise farm animals under less intensive and more humane conditions, which can be done efficiently and profitably. Many of the costs of poultry and livestock production are paid for by the public to the tune of some $120 billion per year in the industrial technocracies of the developed world. The primary beneficiaries are multinationals who are gaining a monopolistic control over the livestock industry. Without public support of alternative, humane and sustainable farming systems, there is no incentive for agribusiness to change factory farming methods because they provide additional profits from the sale of genetically engineered vaccines and drugs to control livestock and poultry diseases in disease-promoting confinement systems. It is fair to say that biotechnology is being applied as a band-aid remedy for the diseases and production-related problems of both crops and factory-farmed animals, whose environments are pathogenic, stressful, and disease-inducing. One product, genetically engineered bovine growth hormone, BGH, that dairy farmers inject to boost milk production, causes a variety of health problems and potential consumer health risks. A more economic and ecologically sound alternative, namely rotational grazing, where cows are moved to fresh pasture at intervals, is a major obstacle to agribusiness in its attempts to get dairy farmers to buy this new drug. Biotechnology companies have been testing and trying to market BGH in developing countries, which would undermine traditional sustainable livestock and forage production systems. The appropriate use of genetic engineering biotechnology in developed and developing countries alike must balance the interests of the people and corporate interests and not undermine good farming practices. Following the discovery that transgenic mice that have been given human growth hormone genes grow twice as big, twice as fast, transgenic pigs carrying these human genes were created by U.S. Department of Agriculture scientists with the hopes of benefiting the pig industry with a new line of fast-growing pigs. But these pigs were smaller than normal, crippled and deformed. They suffered from a variety of health problems as a result of so-called deleterious pleiotropic effects of genetic manipulation, and they died at an early age. Lambs given human growth hormone genes by government scientists in Australia suffered a similar fate. Gene engineers are endowing farm animals with various human genes to turn them into living pharmacies to manufacture useful pharmaceuticals. First mice and then sheep were given the human gene to secrete factor IX and alpha-1 antitrypsin in their milk. There are plans to separate and purify these and other chemicals to help treat human patients for various disorders. Transgenic goats have also been created to produce tissue plasminogen activator in their milk that will help heart attack victims. These developments are called pharmaceutical farming and the animals bioreactors. Attempts in Europe to stop further breeding of Herman, a transgenic Dutch bull, failed. He carries a human gene that will make his cow offspring secrete an element of human milk in their mammary glands called lactoferrin that helps babies absorb iron and fight infections. Many people protested on social and moral grounds and on the grounds that potential animal suffering and the very costs of creating productive transgenic farm animals aren't justifiable, considering the fact that a variety of plants and bacteria, even mushrooms, can be engineered to produce the same or similar pharmaceuticals. Farm animals, notably the cow, are likely to play an increasingly important role as bioreactors and even organ donors. But their well-being and biological integrity should not be compromised in the process. There is considerable public discomfort over the ethics of putting human genes into animals. This is an entirely new relationship with the animal kingdom, a genetic parasitism wherein animals become our surrogates. Multiple industrial uses of the bovine species could lead us to regard animals as mere machines and engineer them into mindless automatons. But perhaps then they would no longer suffer, yet still serve us well. Animal production scientists continue to seek ways to make farm animals more efficient and productive under intensive factory conditions. Yet they are not, for reasons of several costs: ecological and economic, environmental and public health. The annual economic losses in the livestock industry due to farm animal diseases and death are astronomical. They are an economic stimulus for biotechnological correctives like new vaccines, drugs, and genetically engineered varieties of livestock and poultry. But these fixes will not liberate the animals from cruel factory farms or alleviate their suffering. The best prevention surely is better husbandry and public outrage over livestock being kept like robots under intensive factory farm conditions. Today, increasingly, animals are seen as mere aggregates of living matter. The U.S. Patent Office was the first government agency in the world to approve the patenting of animals, thus reducing them to the level of matter as intellectual property, new inventions. The first animal to be patented was the breast cancer-prone onco mouse, developed by Harvard University with funds from DuPont Chemical Company. The biotech industry's rush to patent genetically engineered animals was blocked in Europe in 1993 on social and moral grounds, and on the precedent that plant and animal varieties cannot be patented under European law. But opposition in the US and in Australia failed to succeed in establishing a prohibition or a moratorium on animal patenting. There are hopes of medical advances and corporate profits in developing transgenic mice. Some 10 to 11,000 varieties of mice containing human genes had been created by 1992. A major research emphasis is on understanding genetic mechanisms that influence the immune system. A variety of mouse models of various human diseases, like neurofibromatosis or elephant man's disease, are also being developed. New diseases are also being created by inserting human genes into mouse embryos or by knocking out certain genes in order to study how genes regulate development and influence disease processes. A new device called a gene gun, a small particle accelerator that shoots microparticles of genetic material into mice, seeds, and other living things, is being used to create new and potentially profitable life forms. Since a number of environmental factors are known to cause genetic damage, the practical applicability of creating mouse models of genetic disorders is to be questioned, since human medical applications are likely to be interventive rather than preventive, and probably more costly in the long term. Genetic engineering also has applications in developing biological weapons, the development of which is veiled in secrecy. Without greater regard for risks and costs to society and to the integrity and future of Earth's creation, biotechnology will do more harm than good. Its appropriate use in medicine could do much to reduce human suffering. Under environmentally safe conditions, genetically engineered bacteria can be grown to produce a host of valuable medical and industrial products like interferon. Commerce and industry can benefit from new products like super adhesives developed from the genes of marine organisms. The ethics of respect and reverence for all life needs to be applied as the DNA code of life is exploited. The molecular structure of DNA is like a mandala, reflecting the sacred symmetry and mystery of life. In exploiting animals and other life forms, we should be mindful of this sacred dimension and not regard life simply as a patentable commodity or self-replicating collection of matter. Nor should we forget that the original meaning of the word dominion from the book of Genesis is derived from the Hebrew verb yorad, meaning to come down to have communion with creation in humility and with compassion. It is a call for humane stewardship. With such a sensibility, this new technology holds great promise to help us heal the earth and make the world a better place for all life and for generations to come. Since the completion of the first edition of this video, there have been many new developments that reflect the explosive growth of genetic engineering biotechnology that has proceeded until recently in an ethical vacuum and without full public knowledge or accountability. Now in the US and Europe, consumer groups are demanding government labeling of all genetically engineered foods and food and beverage ingredients. Others are demanding a moratorium on the planting of all genetically engineered crops until scientific studies as to safety and risks have been completed. All of this is a threat to US agribusiness, since 60% of all processed foods in 1999 contained genetically engineered ingredients, and over half of all field crops in the year 2000 will probably be genetically engineered. Europe, Canada, and Codex Alimentarius, the International Food Quality and Safety Authority, have said no to the use of recombinant bovine growth hormone in dairy cows.
Recently, scientists have raised serious concerns over human health risks of some genetically engineered foods. Genetically engineered crops have been shown to cause genetic pollution. Their pollen contaminated conventional and organic crops and killed beneficial and harmless insects like monarch butterflies. Some genetically engineered crops are genetically unstable, more vulnerable to climatic stress, have lower yields, and are not likely, as promised, to help feed the hungry world. We urge consumers to purchase organically certified foods, since national organic standards prohibit genetically engineered seeds, products, and processes. And we urge all people to become more informed about this new technology. It is a process beyond evolution, and we must all work to ensure that it is used to maximize its medical and bioindustrial benefits without cost to the public's health, to biodiversity, and to the natural environment and all who dwell therein.